Welcome to the Math Record. Today I'll be covering the ICTM Regional 2014 Division A Geometry. Let's begin. Number 1, the ratio of two supplementary angles is 1 to 5. Determine the measure of the larger angle. So if one angle is x, that means the other angle is 5x because the ratio is 1 to 5. So you add them together 6x. And since a supplementary, the sum is equal to 180. So that means x is equal to 30. The larger angle is 150 because it's 5 times that angle. Okay. So number 1 is 150. Basically just that simple. In the given diagram, the length of AB is 4 less than the length of uh, BD. If the length of BC is 2 more than the length of CD, find the length of AB. Okay, so let's draw this. So they said if the length of BC is 2 more than the length of CD, so let's say the length of CD is x. That means the length of BC is x plus 2. And they said that the length of AB is 4 less than the length of these two combined. So this is 2x plus 2, so that's 2x minus 2. Okay, so the equation to, this is inscribed angles and lines question. Basically, the property is that the entire length, which is 2x plus 2, times the part outside, which is x plus 2, is equal to the tangent 1 squared. So it's 2x minus 2 squared. This is 2x squared, that's 4, that's 2, that's 6, that's plus 4. And this is 4x squared minus 4 minus 8x plus 4. Okay, so we could cancel out the plus 4's because we already have it on both sides. So then we subtract 2x, so 2x, then minus 14x. So we distribute out the, it's equal to 0. So we could distribute out the 2x, so 2x, and then x minus 7 is equal to 0. So x cannot be equal to 0 because you plug in 0 in here. That would make it negative. So x has to equal to 7. So to find the length of AB, we just need to plug in 7 to here. So 2 times 7 is 14. 14 minus 2 is 12. So that is the length of this. So answer for number 2 is 12. Okay. Number 3, in the given diagram, MA is parallel to TH. Okay, so let's kind of draw this entire thing. Not the best artist, but something like this. So MA is 4x, and AC is 5x plus 2, and MC is 3x plus 4, and CT is x plus 3, and TH is x plus 2. And we have to find CH, so we have to find this length, question mark, right? So this, how you solve this is basically, we know since these are vertical angles, that means both these angles have to be same. And also this angle is equal to this angle because it's parallel, right? So they're just basically alternating angles. I believe I don't know what the specific term is called, but these two angles are the same. That means these two angles are the same. So basically, if you had to do proportions, 3x plus 4 divided by 4x. So this length divided by this length is the same thing as saying our x plus 3 divided by x plus 2 is equal to this length divided by this length, right? And now we just cross multiply. So that would be 3x squared plus 6 plus 10 plus 8 equals 4x squared plus 12x. So that tells us that x squared plus 2x minus 8 is equal to 0. So that means x minus 4, well, x plus 4, and x minus 2 is equal to 0, right? Because x squared up minus 2x plus 4x plus 2x, and then minus 8. So x is equal to negative 4, or x is equal to 2. X cannot equal to negative 4 because if you plug into like 4x, that would be negative 16, and you can have a negative length. So x has to be equal to 2. So this length would be equal to 8. This length would be equal to 10. This length would be equal to 12. This is equal to 5. And this is equal to 4. Right? So 8 divided by 2 is 4. 10 divided by 2 is 5. So 12 divided by 2 is that question mark. So 12 divided by 2 is 6. That's your answer. So our answer for number 3 is 6. Basically, just that simple. Just a lot to keep track of. 4. AB is a chord of O such that the degree measure of minor arc AB is 1/4 the length of AB, of major arc AB. So we have arc AB. This is center O. Okay. And they said this length is 1/4 this length. So if this is 1/4 x, this is x, this is 1/4 x. So 1/4 x plus x is 5/4 x, and that should equal to a circle. So that's equal to 360. So that means 360 times 4 divided by 5, which is this is 72 times 4 is 288. So if x here is 288, that means this is 72. So that means this is 72. And we need to find angle OAB. So we need to find this angle. So since this are both radius, that means this is isosceles. So this angle is equal to this angle. So that means that angle. So if we call that, actually, let's call that angle A. That means 2A plus 72 is equal to 180. So 2A, because that's a triangle, so 280. 2A is equal to 108. That means A is equal to 54. And that's your answer for number 4. Okay. Let's kind of delete this. Okay. Number 5. In the given diagram, AC is parallel to HF. Angle CBD. Okay, so let's kind of draw this out again. Something like this. And they say angle CBD, so this angle, is equal to GED, so it's equal to this angle. And they say angle E is 18 less than angle D, so this angle is 18 more than it, so right here, so this is x plus 18. And the measure of GE is 44, so this is 44. Okay, so what we're gonna do is that we're gonna extend this line out. So we can extend this. So basically the property is that these two angles has to add up. Okay, sorry, my thing keeps breaking. These two angles have to add up to the one that's exterior. So that means if this is 44 and the exterior is x, that means this angle over here has to be x minus 44. Because x minus 44 plus 44 is x. So this is x minus 44. So same case with this. These two angles have to add up to the exterior. So if this is x and this is x plus 18, that means this angle for sure on the top is 18. And this angle are the same because they're vertical angles. Well, not vertical angles. They're x. Well, they're kind of like the same. I can't. Well, since they're parallel, right, and you cut right in between, this angle has to equal to this angle. So x minus 44 is to 18. I don't know exact name, but that's a property. That means x is 62. And we need to know x plus 18 because that's angle D. So 18 plus 62 is 80. And that's your answer for 5. Number 6. Triangle ABC is similar to DEF, and B and E are 90 degrees. Okay, so they're both right triangles. B, E. Let's call this A, B, C, and this is D, E, F, right? They're similar this way. So AB is 4, and DE is square root 2. The length of this is square root x, and this is square root y. Okay, so we need to find k, which is x is equal to ky. So if it's similar triangles, that means you have to scale it right. So that means you have to scale this by 2 square root 2. Because 2 square root 2 times square root 2 is 4. So that means square root x is equal to 2 square root 2 times square root y. So this is the same thing as square root 8. So that means square root x is equal to square root 8y. And you can square both sides to get x is equal to 8y. So that means that k is equal to 8. It's basically just that it. You're just manipulating your variables around. In the given diagram, angle C is a right triangle. Okay, so let's kind of draw this again. Draw length, triangle. And this said the length of BC is 120, so this is 120. And the length of AB is 100 more than the length of AC. So this is x. This is 100 plus x. Plus, okay. And the length of CD is 4 more the length of BD. So this length is 4 more than this. So let's kind of subtract. So 120 minus 4 divided by 2, 58. So that means this length is 58 and this is 62. So this is 4 more than this, right? So because 58 plus 4 is 62, and 62 plus 58 is 120. So that's true. So find the length of AD. So we need to find this length right here. Okay. So all we need to do now is we need to find x, because then we can find the hypotenuse. So we know this is 120, so 120 squared plus x squared is equal to x plus 100 squared, which is factored out as x squared plus 200x plus 10,000. Okay, so we could cancel out the x squares. So 120 squared minus 10,000 divided by 200 is equal to 22. So x is equal to 22. So this length over here is equal to 22. So our hypotenuse is just 22 squared plus 62 squared. Take the square root. So 22 squared plus 62 squared, that is equal to 2 square root 1082. And find your answer to decimals rounded. Okay, so we could just okay, so that is equal to 65, well, to the nearest tenth, so 65.8. That's your answer. But if you want your exact answer, this is your exact answer. So that's the answer. So 65.8 for number 7. Number 8. Okay. In triangle ABC, A is the origin, B is equal to this, so let's kind of graph this out. So A is at the origin, B is at 40, comma 0. So this is A, this is B, this length is 40. And CX lies on the first quadrant, so something like right here. So let's say that's C. If AC is 32, so this length is 32, and BC is 24, find the exact coordinates of XY. Okay, so we're going to have to draw a height. So let's call that height. So now we can split up this 40 into x and 40 minus x, right? Because 40 minus x plus x is 40, so this length is 40. So now all we have to do is use the Pythagorean theorem. So x squared plus h squared is equal to 32 squared, and 40 minus x squared plus h squared is 24 squared. So we could add both. We could multiply the second equation by negative and then add them together. So then that would be, so we could cancel out the h's. So that would be x squared minus 40 minus x squared. So 32 squared minus 24 squared is 448. Okay, and now we just look for x. So this is x squared minus 40 times 40 is 1600 minus 80, but that's plus 80 because there's a negative right here, and then minus x squared, so this cancels out. It's equal to 4480. Now add that together, 448 plus 1600, and then divide by 80, and we get x is equal to 128 over 5. So we know what x is. That's our x coordinate, so it's this length. So that's our x coordinate. So our y coordinate is equal to our height. So our height, we just find that back in. So using your calculator, 32 squared, we could plug this back into this equation, right? So 32 squared, and then 128 divided by 5 squared, subtract them together, and then take the square root to get each, which is 96 over 5. So that's your coordinate, 128 over 5 and 96 over 5. And that is your answer for number 8. Okay. Number 9. In the given diagram, the measure of... Okay, so let's kind of draw this out again. Okay, somewhat decent. Like this, and 2 more. So angle of CBF is 73. So this entire angle is 73. Okay. It's 73 degrees more than A, B, and G. Okay. And angle BD bisects CBG. CBG. Okay. So we know this angle is equal to this angle. And angle and BE and BF trisects DBG. Okay, so we call this angle X, and since this is trisected, this is 1/3 X, 1/3 X, 1/3 X. Okay, and they said that CBF is 70 degrees more than angle C of ABG. So it will be 1/3 plus 1/3 plus this 1. So that is 2/3, 5/3. 5/3 X minus 73. Okay, so adding that all up, that should be equal to a 180 degrees because it's a line, right? So 5/3 plus 1/3 plus 1/3 plus 1/3 plus 1. So that's 1, that's 2. So that's 6 over 3. That's 11 over 3. X minus 73 is equal to 180. So 180 plus 73 times 3 divided by 11. So X is equal to 69. So find the degree measure of E, B, C. So the degree measure is 1/3 plus 1, which is 4/3 X. So we just need to multiply the answer by 4/3. So 69 times 4 divided by 3 is equal to 92. So our answer for number 9 is 92. Okay. Number 10. A right triangle has acute angles such that the degree measure of one is half the degree measure of the other. Okay, so we have a right triangle that's acute, and one is half the degree measure of the other. So this is 30 and this is 60, because half of 60 is 30, and they all add up to 180. That's a triangle. The area of this triangle is 18 square root 3. Find the length of the hypotenuse. So if this is a special triangle, it's called the 30, 60, 90 triangle. So if this is x, the hypotenuse length x, opposite of the 30 is x over 2. Opposite of the 60 is x square root 3 over 2. So that means the area is x squared, square root 3 over 4 divided by 2 is divided by 8, right? So this is the area. So we know the area is 18 square root 3. So 18 times 8, take the square root, that should be equal to x. So 18 times 8, so square root of that is 12. So x is 12. That means our hypotenuse is 12 because that's what we defined it as. Okay? It should be a pretty simple question if you know your special right triangles, which is like the 30, 60, 90, the 45, 45, 90. And maybe if you want to learn one of the special ones that are for the golden ratio is the 72, 72, 36, I believe. And if you want to know like the 1575, which is okay too. 11. A rectangle has diagonal 2 square 3, and one of the side is 2 more than the other. Find the length of the shorter side. Okay, so something like this. This is x, and the other one is 2 more, so x plus 2. This length is 2 squared 13. So using the Pythagorean Theorem, x squared plus x squared plus 4x plus 4. So this is 452. Okay, so 2x plus 4x minus 48 is equal to 0. X squared plus 2x minus 12 is equal to 0. And then divided by 2. Oh, this is 24. Sorry about that. Okay, so we can use 6 and 4. So x plus 6, x minus 4. So that means x has to be equal to 4 because x cannot be negative. So the shortest side is length 4 because the other one's 6. Okay, so the answer for 11 is 4. 12. The perimeter of the equilateral triangle is shown in the diagram is 48. So since that is 48, let's kind of draw. We know this is 4, so this is 4, so this is 4. So if this is 48. 48 divided by 3 is 16. 16 minus 4 is 12, and 12 divided by 2 is 6. So that means these are each length 6. Uh, oops, no, 16, 12. 12, 16. Yeah, so that's right. So find the area of the unshaded. So this is 60 degrees. Each of them are 60 degrees because it's equilateral triangle. So that basically tells us that it's out of 360. So 60 degrees out of 360 is 1/6 of a circle. So the area of a circle is pi radius squared. So the radius is 6. So pi 6 squared divided by 6 because it's 60 degrees out of 360, right? So it's only a sixth of the area. And there's 3 of them, so you gotta multiply by 3. And the edge area of an equilateral triangle um, is kind of good to know. It's just x squared square root 3 divided by 4. So the reason is if this is x, this is 60, 30, right? So as I said before, x squared 3 over 2, x over 2, and you multiply them together, x squared 3 over 4, divide by 2, right, to get the area of this triangle. But there's another one, so you have to times 2, so those cancel each other out. So it's just x squared squared 3 divided by 4, and that's your area. And that's just a quick proof. But this is the area. So now you have to plug in our side length, which is equal to 16. So 16 squared, square root 3 divided by 4. So this is 6 pi, 18 pi. And divide by 4, so that's 4. 16 times 4 is 64. 64 square root 3. Okay, find the exact numerical area. So that's just 64 as our entire triangle, minus the shaded, which is 18 pi, right? So this is your exact area. 64 times square root 3 minus 18 pi. Okay. Number 13. Find the degree measure of a smaller angle formed by the hour and minute hand of a standard analog clock precisely at 10:14. Right, so we have something like hours and minutes, right? So this is 0, 3, 6, 9, right? Some kind of clock. And it's at like 10:14, so something like right here, and 14, so this is at 15, so something like right here-ish. So that's like where our clock is. So this is our hand, this is our minute hand. And find the measure of the small angle. So we have to find this angle, not this angle. This one's the bigger one, so we have to find the smaller one. Okay. So usually how I do this is that I kind of count the ticks in a circle, I mean a clock. So how it kind of works is that we have 60 ticks, right? So 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. So the 5 is going to be 5, 6, 7, 8, 9, 10. And then there's 15, right? Because every single 5 tick is 1 hour. So 1, 2, 3, 4, 5. So this is the first hour. 1, 2, 3, 4, 5. This is the second hour. I'm just really bad at scaling, but here's right here is the 3. So I guess if you want to be more precise, it's going to be 1, 2, 3, 4, 5. So it's first hour. 1, 2, 3, 4, 5. This is the second hour. 1, 2, 3, 4, 5. This is the third hour, right? So every single tick. So since there's 12 hours, right? That means 5 times 12 is 60. So there's 60 ticks. So how this kind of works is that if you're at the 10 o'clock, right, that means your hours are at the 10. So 10 times 5 is 50. So the hour hand is at the 50 tick. And we know that the minute hand is at the 14th, is at the it's at 10:14, right? So it's at the 14th. So the 14 is just the 14th tick. So there's no if and and buts about it. It's just at the 14th tick. So the hours hand is at the 50th tick, and the minute hand is at the 14th tick. But you gotta think about this because it's not exactly at the 50th tick. Because even though because if you have a clock, right, and it's at 10 o'clock, so at 10 o'clock. If the minute hand is gonna move, the hour hand is not staying still and then turn to 11 after an hour. It's moving slowly. So in 60 minutes, it's gonna move the next 5 ticks, right? Because the next 5 ticks is the next hour. So in 60 ticks, you're gonna move. So in 60 ticks of the minute hand, you're gonna move 5 ticks in the hour hand. So you have 14 ticks in the minute hand. So that means you have to add an additional 5 times 14 divided by 60 into the here. So that means our entire hour hand minute tick mark is at 50 plus, which usually I just kind of simplify the 5 and the 60. So 60 divided by that 5 is 12. So this is just 14 over 12. And then, so that's our hour. And this is our minute. Which is still at the 14 tick. Okay. And that's generally how you think about it. Well, generally how I think about it. And now we just need to find the angle between them. Okay. So you could just subtract. So 50 plus 14 over 12 minus 14. So just have the 50 minus the 14, which is 36. 36 plus 14 over 12. That's just 1 and 2 over 12, which is 1 and 1 over 6. So that's 7 over 6, right? So it's third. So we could just say that is 37 and 1 over 6. Okay. So that's the amount of ticks between them. So how many degree measure is each tick? Well, remember there's 60 ticks, right? In the circle, there's 360 degrees. So that means each tick is 6 degrees, right? Because 6 times 360 times 60 is 360. So each tick is 6 degrees. So we just have 37 1/6 times 6. So that answer is equal to 37 times 6 plus 1 is 223 degrees. So now you have 360 minus that one to get the other angle, which is 137 degrees. So we had to find the angle of the degree measure of the smaller angle. So the smaller angle is 137 degrees. So that's your answer. Okay. Number 14. Was that 13? Yeah, that was 13. So number 14. In a different diagram, point A has coordinates 1/3, point B has coordinates 3, 4, and point D has coordinates 2, 1. Points A, D, and C are in the order shown. If the area of A, B, D is 1/3 the area of triangle A, B, C, um, find the coordinates of C. Okay, so let's kind of draw this. Then we gotta draw. 1 is at 1, comma 3. B is at 3, 4. D is at 2, 1. And they said that the area of this is 1/3 the area of this entire thing. So that basically tells us that this length here I call it L, its own this length compared to this length is 1 to 2, right? Because L plus 2L is 3L. So this entire length is 3L. But this area is 1/3 of that. That's why. So we know this is 2L. So what does that change? So you kind of think about it. We have 1/3 to 1. And then to change 1 time, we have to add a 1, and then we have to minus a 2. But this one is a 2L, so we have to change by by a factor of 2. So this one's a plus 2, and this one's a minus 4. So add 2, that's 4, minus 4, that's a negative 3. So that's our coordinate of C. And that's it. Number 15, a triangle with sides with lengths of 4 and 9. If a number is selected at random from the lengths 1, 2, 3, 4, 5, 9, and 1 to 20, find the probability that the number could be a length of the third side. So the rule is that the two small sides has to be bigger than large side. So the three combinations are x, 4, 9, 4x, 9, or 4, 9x, right, in order. So in both of these cases, x and 4 are the smallest. So x plus 4 has to be greater than 9. So x has to be greater than 5. In this case, 13 has to be greater than x. That means x has to be between 5 and 13. So x can only be from 6 to 12. So how many numbers are that? 6, 7, 8, 9, 10, 11, 12. That's 7 numbers out of 20, right? So answer for 15 is 7 out of 20. 16. A circle with area 81 pi is inscribed in an equilateral triangle. Find the exact area of the equilateral triangle. So we have a triangle, and we have a circle with area 81. That means the radius is 9, right? Because the radius of a circle is pi radius squared, so square root 81 is just 9. Okay. So if we know that the radius is 9, there's something in geometry called the in radius, which is basically if you have a triangle and you put a circle inside it, the radius of that circle is called the in radius. So the in radius of this is 9. So the in radius of that formula is basically just 2 times the area of the triangle divided by the perimeter of the triangle. So everything is about the triangle. Okay? So the area of an equilateral triangle, which I brought up before, is 2 times x squared square root 3 divided by 4. And the perimeter is just 3x, right? Because x is the side length. So that means we have 2. Uh, this 2 cancel out with this 4 to make a 2. So that's square root 3. So x square root 3 divided by 6 is equal to our in radius. And our in radius is equal to 9. Okay? So that means x is equal to 9 times 6 over square root 3, which is the same thing as saying square root 3 over 3. So this 3 cancels with this 9, which is a 3. So x is equal to 18 square root 3. Okay, so the exact area that we could plug in, our exact area is x squared square root 3 divided by 4, right? And we already know what x is, so we can just plug that in. So 18 square root 3 squared is, and then divided by 4, is 243 square root 3. And that's the area and answer for number 16. Okay, number 17. Find the number of square units in the area bounded by the lines y is equal to 2. So let's kind of draw a graph. So y is equal to 2, so somewhere here. Y is equal to 8. So this is at 2, this is at 8. And 2x plus y is equal to 10. So if it's 0 for x, then it's going to be somewhere right here, and it's going to be somewhere 5. So this right here is at 5, this right here is at 10. Okay. And x minus y is equal to 6. So if x is 0, y is at negative 6. So somewhere right here, negative 6. And if y is 0, then x is at 6. So somewhere right here. Okay, so something like this. And this is at 6. Okay. So basically, we have to find the area of the region bounded by those 4 lines. So that would be, kind of extend that out. Right, so it's going to be this area over here. So we need to find out what this length is. So what is this? So this is basically just going to be a trapezoid. We're going to find these 4 points. So this, we know that the height for this is going to be a 6. So we already know the height of our trapezoid. Now we need the 2 bases. So the base of the first one, we gotta find this point. So it's gonna be the first linear equation, and y is equal to 8. So when y is equal to 8, 2x plus 8 is equal to 10. That means x is equal to at 2. I mean at 1. Sorry about that. Can't do math. So this is at 1. Okay. And this line over here, so x minus y has to be 8, so I minus 8 is equal to 16, so x is equal to 14. So this is at 14, okay? So we know that's true. So if this is at 1 and this is at 14, that means this entire length right here is 13. So our first length is 13. Now we gotta find this one when it's equal to 2. So 2x plus 2 is equal to 10. That means x is equal to, that's 8, that's 4. So this is at 4. Now we gotta find this one. So this is x minus 2 is equal to 6. So x is equal to 8. So right here is 8. So this is 4, this is 8, so that this is 4 in length. So other length is 4. Okay, so now we basically have everything. Now to find the area is basically at the area of a trapezoid is basically at the two bases together. So that's 17 multiplied by the height divided by 2. So multiplied by 6 divided by 2. So this makes a 3, so that's equal to 51. So the area for number 17 is 51. 18. In diagram shown, triangle ABC, ABD is isosceles with AB. Okay, so let's kind of draw that out again. So they say AB is equal to BD, so these two angles are the same. And the degree measure of CBD is 96. Find measure angle A. So the two angles add up together is equal to the exterior. So x plus x is 2x is equal to the one that's exterior to the third one. So the third one's here, so exterior is 96. Okay, so that means x is equal to 48. And we have to find angle A, which is 48. So that's all you need to do, 48. Okay, number 19. Quadrilateral ABDF is inscribed in a circle with side lengths extended to points C and E. The measure of C is 30. Okay, let's kind of draw this out again. So we have a triangle. So try my best to do this. It's not drawn to scale because I'm not good at drawing. So just pretend that this is like pretty straight. I just don't want to make it really big. Okay, so angle C is 30. So let's say that's 30. Angle E is 40. So this is 40. Find the degree measure of A. Okay, so what you need to know about inscribed quadrilaterals is that opposite angles are supplementary. So basically that means this angle and this angle has add up to 180. So if this is x, this is 180 minus x. Okay. So also if this is 180 minus x, that means this has to be x. That tells us that this triangle is similar to this triangle, but it's just flipped around. So if you take this triangle and you gotta rotate it, like you flip it to the other side and then you kind of move it down here, it's gonna be the exact same thing. So basically what that tells us is that this angle here, and if we call this angle x and we call this angle 180 minus x, this means this is x, this is 180 minus x, this is x, so this, um, oops, sorry, this x, so that means this is 140 minus x, so that means this angle has to be 40 plus x, because it has to be 180. So this is 40 plus x, because opposite sides are supplementary. This is 140 minus x. Okay, so it's the same thing with this. This triangle over here, right, it's not drawn because it's not really perfect. That means this angle has to be equal to this angle right here, right? So this, because it's a straight line, so this 180 minus x. And this is straight line, so this 40 plus x, so this angle has to be 140 minus x, right? So we know this 180 minus x, 140 minus x, so that's 320 plus that 50, which is 350, minus 2x has to equal to 180. So that means 170 is equal to 2x, and x has to be equal to 85. So the degree measure of A is 140 minus x. So 140 minus 85, that is equal to 55. So yeah, so the angle measure for A is 55. Okay, so basically just a few rules you need to know. And you basically have to find for similarities, usually for questions for geometry. Question 20, degree measure of the smallest smallest interior angle of an n-gon is 120. The angles each have a interior degree measure that's 5 more than the previous angle. Okay, so the smallest is 120. The other angles each have a degree measure that's 5 more than the previous angle. So if the first one's x, that means the next one is x plus 5, and next one is x plus 10, and the next one is x plus 15, and etc., right? So find all possible values of n. So what we're gonna do is that we're gonna keep tracking the sum of the angles. So let's say if we have only two side lengths, right, it's just 20. If we have only one side length, we have 120. If we have two side lengths, we have x plus 120. If we have three side lengths, right, we have add these together, so that's 2x plus 125. If we have four side lengths, we have a 3x plus 135. If we have five angles, right, we have all that, so we have 4x plus a plus a 150, right? So what we could do is that if you want to get the equation for this, it's we could just look at the pattern. So at the fifth one, which is five side lengths, right? So it's be n, because that's the amount of side lengths, n minus 1 times x, right? Plus 150. Well, not plus 150 because we gotta determine this pattern, which is 5, 10, 15. So it's like a quadratic. So usually what I'm gonna do is that I usually like to use a regression on my calculator to find it out because I'm kind of lazy and I don't want to like find out the quadratic equation by myself. So usually what I do is that I put it in a calculator. So when plug in x and a y, so when it's 2 is equal to 120, when it's 3 is equal to 125, when it's 4 is equal to 135, and when it's 5 is equal to 150. And if you make a regression out of that, you will basically get the equation of what it would be. So let's see what that is. Analyze, regression, quadratic. Okay. So a regression is 5 over 2x, n squared, minus, that's 15 over 2n, plus 125. Okay, so that is gonna get us the constants, the 120, 125, etc. Right? It's not gonna count for the first point because it's the data doesn't scale really well because this is 120 and this also 120, so it's kind of weird. But for sure, this is gonna be this works out for like a bunch of the equations because you could just plug in the numbers. So let's say like you plug in 5 for n, so it'd be 5 times 5 divided by 2 minus 15 times 5 divided by 2 plus 125, 150, right? So this equation is true. So we know this is going to be the general form for the sum of all the angles of a polygon given n sides, right? Okay, so let's move that over and kind of write this a little bit more cleanly. So it'll be n minus 1 times x plus 5 over 2n squared minus 15 over 2n plus 125. Okay, let's delete all this. Let's kind of move this. Okay, so that's the general formula for the sum. So the sum of an n-sided polygon is gonna be 180, n minus 2. That's the sum because if you have a triangle, that's n is 3, 3 minus 2 is 1, so that's 180. If n is equal to 4, that's a square, right? Or a rectangle or quadrilateral for a specific name. 4 minus 2 is 2. 2 times 180 is 360. This is general formula for the sum of all the angles. And this is the sum of all angles for our particular case. So we need to find out when they're equal to each other. right? So find all possible values of n. That's basically what it is, right? So we have a so the degree measure of the smallest interior angle is 120. So we have n minus 1. So I'm just gonna copy and paste actually, because then we could like simplify this pretty well. Okay, this is equal to 180 n minus 360. Right? I just simplified that out. And now we don't need any of this anymore because we just need to find out all values for n. Okay, so let's move that up. I'll be working with this equation right now. Okay, so we just have to find n. And we have to make sure x has to be greater than 120 or greater than or equal to. Because they said the smallest interior angle of the n-gon is 120. So we gotta make sure that the x cannot dip below 120. Okay, so all we have to do is just move everything to the other side. So we have n minus 1 times x is equal to negative 5 over 2 n squared. Um, this is plus the 15 over 2 plus that 80. So let's kind of find out that out. So 180 plus 15 divided by 2 is plus 375 over 2n. And that is just minus 485. Okay, and that will be equal to our x. So x is equal to negative 5 over 2 n squared plus 375 over 2n minus 485 divided by n minus 1. Okay, and that should be equal to our x, right? So so they said that x, so based on the thing, it says based on our question 20, x has to be greater than or equal to 120, and also has to have integer. So x also has to be an integer. So now what we're gonna do is that we're just gonna plug this formula into our calculator, and then we're gonna find out what values work. Okay, so let's see. So negative 5 over 2, oops, negative 5 over 2, uh, so negative 2.5 actually, times x squared plus 375 divided by 2 times x minus 485 divided by n minus 1. Sorry about that. X minus 1. Okay, so if we plug in 2, that's a negative. That doesn't work because x has to be a positive number. You can't have negative degrees. So we have plug in some numbers. If you plug in n is equal to 3, that's a decimal. Doesn't work. It has to be integers and it has to be greater than 120. So it fails both cases. 4, 5, 6, 7, 8, 9. Okay. So 9 gives us when n is equal to 9, our x becomes 125. So that works. 10, 11, 12, 13, 14, 15, 16, 17. Okay, 16. When n is 16, it also gives us 125. That's our integer. 17 doesn't work. It's a decimal, decimal. So after that, like after number after n is equal to 19, it starts becoming more negative, right? Because it's a parabola concave down. So it's gonna get smaller. So n is gonna get lower than 120. So the only possible answers are n is equal to 9 and n is equal to 16. So these are the two possible answers. So generally for this, you might just need to know how to use your calculator and make like a general rational equation. And you can just start spamming away in your calculator and you'll get the right answer. And that's question 20. Okay, as a review, generally, probably the two last questions are gonna be the hardest because it's to think about. 19 is just really weird to think about with triangles and circles and quadrilaterals at the same time. 20, you have to think about equations, which is super weird and it's trial and error. But everything else, as per review, you need to know what exterior and interior angles are. Know what polygons are, like how to find like elements of polygons, like number of diagonals, the side lengths, the angle, interior angles, exterior angles, their degree measures. There's some of them, and find out how to like find areas under like graphs, and know general formulas like equation of a circle, and also general formulas like what makes a triangle. And know for sure you gotta know the equation for equilateral, which is x squared square root 3 divided by 4. This is one of the most important equations to use for equilaterals in geometry tests. This is one of the most used. So you probably just want to memorize it because it will speed up your competition really fast. Other than that, just know Pythagorean theorem and basically similarities. And that's basically it. Well, thanks for watching, and I'll see you at the next math record.